So we are now doing this content analysis. We covered title, we covered abstract and introduction. Today, my plan is to cover all these: methodology, results, discussion, and conclusion. So let's see how far we can go. So methodology is the first topic. I hope you still can see my slides.
Yes, sir.
Okay. So when you plan to write your paper, probably you will be thinking, where should I begin? At the beginning, it will seem to be quite a big task. So as I mentioned in the last class, so there is a technique, we call it divide and conquer. So it's a general technique. Whenever we have big tasks, we divide them into small segments. And then we think of those small segments, try to finish them one by one, and eventually we finish the whole task. And we apply this here as well in the paper. So we think of our paper as something consisting of small portions, and methodology is one of them. And most people find this methodology very easy to write. So the tactic is you try to write the easier things first so that you have some motivation, you have some something that will drive you forward. So this is the most easy place to start. And I think you can realize why it is easy. Because this one is just simple description, what you have done in your study. And the way you have to write it is that you have to give as much detail as possible so that others can replicate it. So that is the method, the scientific method. So as a researcher, we publish something with the hope that somebody will try to validate this. They try to do the same experiment and see if the results are the same as we have found. And in the last class, I also mentioned that methodology becomes so apparent in the early stages that they have included this in the inbred format in a very strict manner. And we don't have much space here, so we have to be quite brief. But at the same time, we want to be as complete as possible. We give the essential data, information, so that somebody else can repeat the experiment. Typically, it is written in past tense when you write a paper because you have completed your experiments. However, if you write a proposal, then it will be in future tense because you will be carrying out the work sometime in the future. In the methodology section, you can write down the references if necessary. Sometimes it can be a quite large section. In those cases, you divide them into subheadings because then it's easier for the readers to follow. If necessary, add figures because figures always help. Never include any result in the methodology because some students do this mistake. So you cannot be too lengthy. At the same time, you have to be complete. So there has to be a balance to be struck. And the rule of thumb is if you have a new method, a new instrument or new type of data which was not reported by others, then you have to give detailed description. However, if the method is very well known, the equipment is available commercially, then you may not need to give every detail. You may give sufficient reference after giving a very brief description. As for chemicals, you have to use exact technical specification. Avoid using trade names in the chemicals. It is expected in a scientific paper you have appropriate statistical analysis done in the paper. So if so, you have to give details of the statistical methods that you have used. And remember, whatever result you describe, every result must have a method. So do not miss any method, even the minor ones. You have to explain that. But of course, the minor ones may not get as much space as the most important ones. This section may have different names depending on the type of your work. If it is a paper based on numerical work only, so it could be computational technique, it could be instrument and measure in some cases, data analysis and technique if it is just analyzing the data. But for experimental papers, normally we write methodology or methods or materials and methods. So when you have experimental paper, in the methodology, you may have to describe the equipment, materials, and methods. If it is a modeling paper, then obviously you have to give the assumptions, mathematical tools used, and so on. For a computational paper, you have to describe the computational method and then give the inputs and tools that you have found, that you have used. Now, since it is easy to write, some students take it not so seriously. But remember, when the reviewer will read your paper, then he will put a lot of emphasis on methodology. And he will see how you used your methodology in order to achieve the result that you have claimed. And he will see, can he trust that the results were obtained by the methodology that you have described. If he is not convinced, he can or she can reject the paper. So don't take it lightly. For instance, I give you one example. So let's say you claim in your result an accuracy of a figure which is, let's say, 0.0039. So 4 figures after the decimal, just a simple example. Now, he may choose to look at the methodology that you used, the equipment that you used. Now, if he finds out, if he's an expert, I think he will be able to find out. He finds out that the methodology that you used can give an experimental accuracy of just 2 figures after decimal. Now, if your claim is this, and if he knows and if he finds out that this is the actual situation, then he may reject your paper. So please pay particular attention and be careful about what methods you are using, what equipment you are using. Know your equipment in detail. Our next topic is results. John Wesley Powell is a US explorer. He was a famous geologist, but in his early career, he was a soldier as well. And he is famous for collecting a lot of geological data in the US. So he's telling us that collecting facts and data is easy. Any fool can do that. But as a scientist, as a researcher, you have to select the proper data, and that needs wisdom. That needs wisdom. So that is very important for us. So you as a researcher must keep that in mind. You will carry out a lot of tests, you will get a lot of data, but you cannot include all of them in your thesis. You cannot include all of them in your research paper. So you need to select them. You should have the ability to select them. But again, we have to be very, very ethical and professional, so that we must not forget about selecting the data. So we have to have the ability to select the representative data. So that is the key word. So we just don't reject or accept any data. Representative data. I will not write it down. So we have to do this practice. Now, as I mentioned, you will carry out and get a lot of results. So you don't have to put everything in the paper because the space is limited. So what you have to do, give only the key results. So the results that you will include will depend on how you formulate the problem in the introduction. In the introduction, you will present the research question or hypothesis, and then the results that you choose will support those hypotheses or answer those questions. So this is the heart of your paper. Research is basically the building block. And normally what we do is, after we collect the data, which is primary or secondary in nature, we put them in the form of graphs, tables, and figures. So that is the first task we do. And then we assemble them. We lay them out on a big surface like a table, and we have a look at all of them. We try to see if there is any link between different groups of results, any contradiction between them, so that you can come up with a story. And in order to tell their story, in fact, paper writing is basically storytelling, as in many other types of communication. So in order to tell a story, you have to order the results in a proper manner, in a logical sequence, so that audience can follow them one by one. And out of this exercise of laying them out and then trying to get a story out of it, you will get the central message of the paper, which will lead to the main conclusions that you get. So, as I already mentioned, you have pre-selected papers for your, pre-selected figures for your table. You arrange them logically. And you do it in such a way that you guide the reader through your findings in a very simple, clear way. And on this journey, you keep on stressing the main points, the major points. Whatever your selection is, you have to be very accurate and consistent. And when you describe your result, you will describe in language, but whenever you have the opportunity, you try to be as quantitative as possible. You give the magnitude. If something is changing, increasing, or decreasing, you give the magnitude and try to give a sense of rate of change, like percentage of change, how much it is changing, etc. Again, as in any other sections, you have to be very clear and simple. Sometimes we separate the results and discussion section. Sometimes we can combine them. It depends on our type of work that we have done and also on our personal preference. Now, when your results and discussion sections are different, then you have to select what to put in the result and what to put in the discussion. So in the results section, you only describe the results. Do not do much interpretation. Only a few here and there if that is absolutely necessary. But keep all the discussion and interpretation for this next section, which is your discussion section. So remember this basic rule, the results only for results. And then you do the discussion in the discussion section. Each of your figures and tables must be standalone. And each of them must be referred to in the text. So there cannot be any figure, any table unaccounted for in your table. The caption that you use for each of them must be short and self-explanatory. You have to make it in such a way that the reader can get easily what message your graphs or figure is given. If you have photomicrographs, then you must not forget putting the scale bars. Otherwise, it would be confusing as to the size of different features. In results, obviously, you will put data, you will convey the data, and you have to keep in mind that each data has 4 characteristics. It has a description, the characteristic, the nature of the data, then it has a number, and typically it will also have a unit. And then when we measure something, we know that we cannot measure it with 100% accuracy. That is impossible. So there will be some error in them. There will be some uncertainty. So you have to measure that uncertainty. And then you have to show them as plus minus the error that you have. And in a plot, you try to give, or in your paper, all this information as much as possible. So we use error bars whenever we have a point. For instance, if you have one point like this, another one like this. And if you want to plot a trend curve, you can obviously plot them. But just this one point is not enough. You have to collect at least 3. It depends on the field. It depends on the technique. And if you have 3 measurements for each of them, you will not have the exact value all the time. So there will be some error. And that error is shown as error bar. There are different ways of calculating the error bar, as standard deviation, as standard mean or something. Whatever you do, you make it clear in the paper and then put them in the, because if you don't do that, then people will not believe you. And even with the same figures, with the same points, you can have very different conclusion. Now your conclusion is this x, y is rising as a function of x. But if you put the error bar differently, for instance, your error bar looks like this one. In that case, it will be very difficult to convince the reader that it is increasing, because your error bar has got a lot of uncertainty and it is not convincing that you see a trend there. So you have to be careful about this kind of cases. So again, from Elsevier, so you need to give the representative results. And you should not hide any data with an intention that you want to say, publish them in another paper. If the data that you have collected is necessary for this present paper and it's important for this present paper, then put all the data. The result is written, if it is a lengthy one, with some subheadings, because this always helps the reader. And of course, I think we know that figures are very important and we use a lot of figures. I think this is understood. And one other thing you must not do is that when you have a set of data that you give as a figures, you must not give the same data as tables. So that is totally forbidden. So you have to choose any one of them, not both of them. And the figures that you give must have some substance, must have some data. If it contains very few information, then you shouldn't give them as figures. Rather, you have to just describe them in a line, a sentence or two in your text, like the comments that you can see from one editor. So editor is obviously annoyed that the author put very little information in the figure, and this information could be just written in a sentence or two. And of course, the legend of the figure should be as brief as possible. And it should have sufficient detail so that the readers do not have to go to the text to understand the figure. So when he flips through your paper, he should be able to understand each and every figure. So the figure caption must have all the essential information. And don't put too much information in one figure. Don't make it overcrowded. 3 to 4 sets of data per figure is good enough. Otherwise, if you put a lot of curves in one figure, then it's difficult to read. And as for the use of color, you have to be very careful, because remind yourself that many people would get a photocopy of your paper in black and white. So if you do not select the colors carefully, then in black and white print, the readers may not be able to distinguish between different figures, which is not good. And try to avoid tables, but there are cases where we must use table. But in general, we try to avoid tables and we put data in graphical form. And you have to pay attention to the quality of your figure. So this kind of figure, where you can see the quality is not good enough. You have to make sure that everything can be read. It is clear. There is no confusion. And in that sense, this figure is probably a good one. It's written best. It may not necessarily be the best, but it's a good one, obviously, because you can see the trend line is given, the symbols are given, and there is no confusion. So even in this area, you can see which graph is what. There is no confusion whatsoever. So you give both the symbol and the trend line. This is another thing, when another figure that also gives you some idea about what a good figure should look like. Okay, so in the axis of the figures, try to have minimum number of ticks, and you don't have to number each of the ticks, otherwise it will become too crowded. So if you have, let's say, 3 or 4 ticks in your figure, then you put the number in major ticks. But for readers to get the idea easily, that you can put some small ticks, but you don't have to number them. This is just as for guide to the eyes of the reader. So that is okay. And remember that your figure may be shrunk into small 1-column format. In such a case, if you do not have large enough fonts, then it will be difficult to read. So you have to anticipate this reduction. And after the reduction, your letters in the figures should be about 2 to 3 millimeters in height. Avoid using bold letters, because then it creates problem when you shrunk them. So as I mentioned, a little bit more about the color. So you can use the color, but remember, you have to make sure that when they're printed in black and white, they should still be visible and distinguishable. Now, one way to do that is to use different line styles. So in addition to the color, if you use different line styles, then it is easier to achieve this objective. For instance, if you have these 2 curves, so if you could write one curve, plot one curve using this dotted line, another one is this sort of pattern, then it will be easier for others to follow. Just one example. So this graph, if you plot it, if you print it in black and white, then you lose the sense of which graph is representing what. Where does it start? Where does it end? So you have to avoid this. This is another one. This is one. If you plot it in color, it looks nice. If you plot it, then some confusion arises. For instance, at this point, is it going this way or is it going this way? Now you can easily avoid them by using different patterns. So even in black and white, you can clearly see which graph is starting where and where is it going to. As I mentioned, sometimes, very often, I think your paper will be written in this 2-column format. So your figure will be very small. This should be after this reduction in height. Okay. So each table will have a short title, and each table and figure, the same goes for figure, must be referred to in the text. I think I mentioned this already. I just want to highlight it once again. Don't give the data in 2 forms. Just use 1. Another thing you will notice probably that when it is published, publisher usually don't use vertical lines, because then it blocks the flow of your eyes as it moves. So normally they use the horizontal lines only. So if you know the trick, then you can already prepare your table in this form. So when you write your results based on the graphs, etc., in the result, you are expected to write only the result. And the methodology section gave the details of the methodology. However, when a reader reads a paper, he may have forgotten what exactly were the parameters in the methodology. So in such a case, it is allowed that you give a very brief description, 1 or 2 sentences, of the relevant methodology of a particular subsection in the results. For instance, if you look at it, the first sentence reminds the readers about the methodology, or what was the concentration that was used in this particular subsection. So this helps the reader, but you are not allowed to give the details. Just a sentence or 2 should be good enough. So after you have reminded the context in the methodology, then you are describing the results. When you describe the result, it is an important practice that you refer to a specific table or a specific figure. It's very important. You just cannot describe the result in vacuum. You have to refer to them, to the graphs, to the tables that you have put. And once you describe what that graph shows, then you can give your observation about the graph. So what the graph is showing. So you describe them, you explain them. If you are writing results separately from discussion, then you don't have to give the interpretation, too much interpretation here. Keep them for the discussion section. Let's look at the discussion section. It is probably the most difficult section in your paper. In fact, it is the most difficult section. So the purpose of the discussion is that you have to interpret, synthesis the results that you have presented, synthesize the results. And based on this, you may have to make some futuristic speculation. What will happen if you change the parameter to different values? And you also try to interpret your results. You compare it with the theory, with the principles. You look at the relationship between different types of results that you have. You try to see that the results that you obtained, can you make it presented in a more general manner? Can you universalize it based on the theory that you have? And obviously, the explanation is important. So you need to explain all these characteristics of different results and their relationship. So these are some points that you can use while you are writing your discussion. So what you have to do, the results that you are presenting, how does it relate to the original research question or hypothesis that you presented in the introduction? So you can start with that one. And then you try to see what are the relationship between different results that you already obtained. So you have 5, 6 sets of figures, for instance. Do they tell something when you look at them in a combined way? But of course, each of them will give you some information individually. But when you connect them, when you look at them together, they may give you some new information. So those are the things you have to describe in the result. Then you can compare your result with the previous work described in the literature. This is very important as well. And see how far your result is conforming to the previous result or how far it is differing from the previous result. And then try to explain why is it so. Was there any reason why you got a different result compared with others? Can you explain them based on theory or based on any other empirical observation? If it relates to engineering practice, you can also relate your paper to current engineering practice and suggest some modification or changes in the practice. If you have something which is very unique in your results, some exception, it doesn't follow the theory, then you have to be careful. And perhaps it can give you some very valuable data if you can interpret them. So you have to be very careful when you have this kind of exception or lack of correlation with the theory. Then you will probably be discovering something very new. So you never know, so you have to pay a lot of attention. When you interpret things, obviously you will give your own interpretation, your own point of view. But there could be a different point of view given by others in the literature. So you have to then describe both points of view. You have to describe your side of the argument and their side of the argument. And then you have to tell which one you believe is correct and give the explanation. So this is how you logically suggest your own interpretation. So in the discussion section, your structure may look like this. So you start from your own findings and then you relate it to the literature, you relate it to the theory, relate it to the practice, and then explain them, interpret them, and so on. So structurally, it will look like this. This is your result, which is very specific. Now you want to compare them with the literature. So you want to go more general, compare with the theory, compare with the practice, and so on. And avoid any repetition between results and discussion, any redundancy. So in the result, you just give the result, and then you do the real discussion in the discussion section. And you do not have to discuss each and every points, minor points. So you only have to discuss the major points, the most important ones, significant ones. And remind yourself all the time that discussion is very, very important. And many of the papers are rejected just because of this weakness in discussion. You remember you have to target Q1 journals. And for Q1 journals, discussions are extremely, extremely critical. When you discuss, you have to discuss it in relation to your own result, very important. But of course, you can compare with the literature. Okay. So these are the checklists. So once you have written your discussion, then see if it is a balanced discussion. See if it relates to the original thesis or original hypothesis, original question that you raised, the original problem that you defined. How does your result give a solution to those original problems? So that is the first thing you check. Then you have to see the explanation that you are giving. Is it supported by the data? The hypothesis that you are presenting, it must be supported by your data. How does it relate to the other investigations? If there is any weakness in your own work, in your own technique, you are not supposed to hide them. You have to explain them. And if you do it properly, then it will not be looked at negatively. Rather, it will be looked at positively, that you are honest, you are explaining the drawback, and then you are suggesting how to overcome those drawbacks. You can always interpret things in different ways. So don't just stick to one. Try to see if you can interpret your results from a different perspective and then compare multiple perspectives if they exist and then give your opinion. You can also suggest future work, because during your work, you will find that there are new things coming, new problems coming up that suggested for future references. Whatever you do, don't exaggerate things because it will be read by experts. They know things. And if you tell something which doesn't have any basis, then it will be considered as a negative point for you. And try to avoid these sort of things. Extremely enormous, considerable, exceedingly, these kind of words are not quantitative. They're not too scientific. So try to avoid them. So discussion, as I mentioned, will interpret the result. It doesn't have any single format, so it depends. But there are a few formats which is widely used. For instance, when you write the discussion section, the convention is that you remind the major findings. Obviously, in the result, you describe them in detail. You wrote a few pages there. But here in the discussion, you cannot repeat them. So you paraphrase them and then give the most essential results that you obtained. And after that, you do the discussion. And you pick up a few major points from the result and then you discuss them. But always focus on your result. So that should be the center point in your discussion. And towards the end in the discussion section, you could write kind of summary or the conclusion that you write. Probably it can go to the conclusion as well. So I show you a small case study on the discussion so that you see how depth you may have to go. Let me just have a look at it. Okay, so this is one example. This is a paper that a student of mine wrote quite a long time ago. And the reviewer was asking that this paper lacks some in-depth discussion. So it needs to have in-depth discussion to explain certain phenomena that was observed in the paper. And I show you just one section that will give you some idea. Let's see. Now let me give you the background. So this is a work that was done to see the effect of nanoparticles on lead-free solder, tin-based solder that is used to connect the chip in an electronic device with other connections. So here the theory is that the hypothesis is that when you add proper nanoparticles inside the solder, then it should improve the property, the structure and property of the solder joint. And this student added cobalt into the solder, and the reviewer were not happy at the beginning. They asked that the student must explain how the cobalt is influencing the microstructure and property. So after it came back from the reviewer, the student tried to write this, and then the student gave this explanation. And if you can just read it quickly to get the idea. So basically you have to relate it to the work of others. So that's what the student is doing. That effect of cobalt was investigated by only few people. And then the student is writing what were found in those earlier study. And there were both experimental and theoretical calculation. The student described what they were found. And Actually, I made a mistake. The student was doing the effect of nickel, but the effect of nickel was, let me explain again. Yeah. I think I'm confusing you. So the student was doing, let me write it down. In fact, cobalt. And when the reviewer asked the student to discuss the effect of cobalt, the student was puzzled. The student's argument was that there is no paper, enough paper in cobalt. How can I explain? So you may encounter this kind of situation. So if that is the case, then if you are working in this area and you don't have any other work in this area, you cannot explain it because there are not many work here. Then you have to expand your consideration. You have to see what are the papers which are published in a similar situation. The student discovered that there are papers on nickel, quite a number of published papers are there, and the effect of nickel are explained there. Now you can correlate them. So you can argue that nickel and cobalt, they are similar in nature as chemical elements. So the effect that is found for nickel would also be valid for cobalt as well. And that's what it is telling you. So you need to go down to this kind of in-depth analysis based on the literature, based on the theory, based on the thermodynamics, in order to make sense of the result that you obtained. Let's go back. So our next section is conclusion. So the conclusion, we have three different components in a balanced conclusion. It's not just the summary of the results. So some people, they tend to think conclusion as a summary of the result. Obviously, summary of the result will be there, but a good conclusion will also have some additional contents. Like before you write down the summary of the results, you may want to restate the aims of the study, because then the reader finds it easy to follow, because he read the aims of the study long before this. He read it in the introduction and he or she might have forgotten. So you remind the reader what was the aim of the study in a simple and brief manner. Then you briefly describe the results that you obtained in a summarized form. And that is not sufficient. Now you have to give the significance of the result. You have to give the implication of the result, how it can be used, utilized, how beneficial it is, what are the limitations of the results that you obtain. So in order to avoid the limitation, what should be done in the future? So that sort of message you can give towards the end of this discussion. Then your discussion, end of your conclusion, then it makes the conclusion rich. So here are some patterns of these moves. For instance, restating aims of study. So the language you can use, the aim of the present research was to examine so and so. So you very briefly tell the aim of the study, purpose of the study. And then you summarize the main points. So these experiments show that this and this, and etc., etc. Then the third move will be to give some forward-looking ideas, interpretation, implication, use, possible application in the future. And it could be it could take many different forms depending on your field, depending on the type of results that you obtain. It could be that it has implication on the field of knowledge. So these results indicate that this and this. You can suggest some new kind of study. It can explain the significance or contribution of the study. It can show the limitation that this results is valid only for this set of parameters. Beyond this, one needs to carry out some other tests, and you can tell this future stories. You can provide recommendations, if applicable, for the practice of policy, if that is applicable. So the conclusion must not be the repetition of the abstract. Remember this. So it will give a proper scientific justification of your work. And it will give some extension if appropriate. You just don't stop at your own summary of the results that you obtained, but give something for the future. So I think we are towards the end of this lecture today, and I have a question for you. That is, what are the differences between abstract and conclusion? So I want you to participate in this discussion in an energetic manner. Abstract, conclusion. So who can start?
Sir, I'm Raisa.
Raisa, please.
Sir, abstract. So firstly, abstract, there must be a methodological part, but in conclusion, there won't be any methodological part. This is the main thing. Secondly, there won't be any future application in the abstract, but in conclusion, there must be the implication and application of the research or topic of in the future, and in the abstract there must be the discussion, and there will be a part of results, and in the conclusion there won't be the part of any results. That's it, sir.
Okay. Anybody wants to add something more to this? We need some discussion on this point to clarify something. Don't worry if your opinion contradicts the opinion of Raisa or me. You just give your opinion. I need some feedback. You cannot keep quiet. So, we're still there. And today, whom should I? Salman, what do you think? Salman, are you there? Salman 1, Salman 2, Salman 3. So Salman is actually absent. Then I go to Aliful Islam. What do you think? Aliful Islam, are you there? Yes. Can you give your opinion, Aliful? Oh, Salman has a problem there. Okay, Salman, I got it. Aliful, what do you think? You don't want to speak out. You have to participate in the discussion. You also have no microphone. Okay. Now let me go to Sabbir. I saw Sabbir in every lecture. Sabbir, what do you think?
Sir, the abstract follows the IMRAD method where there was introduction, methodology, uh, and conclusion, etc. But the conclusion part where we can some hints from the introduction, and we can talk about the future future importance of the topic, and I think this is the basic difference.
Okay. All right. Thank you. I think this summarizes the thing. Let me. So what happens is this one. If you look at the abstract, we know that this follows the IMRAD format. So it must have introduction, it must have methodology, it must have results, and it must have discussion. Now here the discussion is a little bit loose. It could also be a conclusion. It could be implication as well. Now, when you look at the conclusion, we have seen that a balanced conclusion will have three main parts. So part one is restatement of the aims and objectives of the paper in a very brief manner. And then the second part is the summary of your results. And the third part is your implication or application for the future or whatever it is. Now, if you compare these two, so let me just cross this out. Aims, objectives, etc. This is coming from the introduction, if you remember. So these two may be similar, but it depends. So it may be that in the abstract, you may use a part of it as introduction. It's possible. Or you can use different part of the introduction. That is also possible. The second thing, methodology is absent in the conclusion. Usually we don't write methodology in the conclusion. We don't talk about it unless it has got a special meaning, unless it has, if it is a new technique, you have developed the technique, so obviously it will come into your results. But normally we don't deal with methodology in the conclusion. Then comes result. And you see that in the conclusion, you also have results in summarized form. So in the conclusion, you have more space. It can be 1 page, 1.5 page. So you give a longer version of the summary, but in the result, your conclusion, in the abstract, you have very less space, very small space. So your result will be very small compared with the results that you give in the conclusion. So maybe a small part of it can come to this. As for the conclusion, you have more space to write down the implication, significance, usefulness, and so on. And for abstract, your discussion may contain that part of it. But your space is limited, 1 or 2 sentences. So you have to distill some of these and then bring them here, if these are relevant. or you could use other part of the results, other part of the discussion here. That is also possible. So the main point between abstract and conclusion is that the purpose of them are different. Abstract is basically a micro paper. It contains everything: introduction, methodology, results, and discussion. The conclusion is intended to give you the essence of the work that you have done. And you do it in a way that is easy to read. So you first provide what was your intention, then you give what you have obtained, then you give the implication, benefit, drawbacks of what you have obtained. So I hope these two are different, are clear to you, to all of you. I think I will. So in a way, this looks like this. Remember, the introduction was like this, inverted triangle. There are general things, you go to specifics. Now the conclusion and discussions are like this triangle, upright triangle. So your results is specific. You have done your work in a very narrow bandwidth, very narrow range of parameters. Now you try to relate it to bigger context. So that is why it will go from specifics to more general. I think I'll skip that. I will, as for the reference, some students tend to think that they have to give a lot of references. That is not true. You only cite the most important references. You don't have to overinflate, because the editors do not look at it positively. And also, do not, if you publish papers previously, don't use too many self-citations. And the last thing is that when you write the references, follow very strictly the style given by the journal in their guide for authors. And you have to follow really very strictly. And it is your responsibility as the author to write it in a correct format. And pay particular attention to the spelling of the names of the authors, because some of the names will come from different culture and we are not familiar with them. Also, try to put the full stop and comma as the right places. And this is coming from a frustrated editor. So this is a real example. So Elsevier is showing this example from one of its frustrated editor. You can read. So he's now totally upset. He's telling you that your list of reference is a total mess. So this is not a professional word, but he's really upset. And if the editor is so upset, then you can easily expect what kind of decision he will take. And the decision, I can tell you, will not necessarily be positive. It will not be necessarily in your favor. So please take a lot of attention in writing your references. Okay, so I think we have done all the major points. We have finished title, abstract, keywords, abstract, and then introduction, methodology. We started today. We finished the results. We finished the discussion and conclusion. And one thing you have to remember, writing is really not easy. You have to put a lot of efforts in writing. There is no shortcut to success. You have to do practice. You have to start writing even today. And one thing which is very positive is that it's not something that you cannot do. Although you will feel that you suffer at present, but at the end of the day, you can cross this ocean and you can reach at the other shore successfully. And that is sure if you put your best efforts. The last thing I want to tell you that whatever you learn, you must apply. Otherwise, your learning is meaningless. So whatever we are discussing, keep notes. And when you write your first paper, look at those notes and check the quality of your each section against the notes that you have taken. One last thing I have to tell you. Sometimes some students publish, but because of hastiness, because of not being careful enough, they submit wrong results. And somehow that result may get published, then you suffer for the rest of the day. Not the rest of the day, in fact, the rest of your life. So never ever give any wrong results. You have to check, recheck, cross-check, and check again before you submit anything. So I'm done with this. Any question, I can spend a few more minutes with you. Question by anyone is welcome. Any comments, questions so far? Any suggestion for, because we still have a few more lectures. Any suggestion for the remaining of the lectures? Who can give us the suggestion? Rashid, do you have any suggestion?
Sir, after the webinar, can you check any of our manuscript by you? It will may be helpful for, but we can write a paper or the part of the paper, and we can check.
I think that is a very good suggestion. Yes, Rashid, I can do that, but then somebody has to give it to me. Give it to me well in time ahead so that I find the time to read it. If I cannot do it for the whole paper, at least for the part of the paper, I think I would love to do that. So anybody, it's an open invitation if you want to have a discussion on your own paper. So please try to give me as soon as possible. Good suggestion, Rashid.
Thank you, sir.
Okay, so if not, thank you very much. We see each other tomorrow.